Hello! Yes, and welcome to our Objective 5.2 notes, graphing polynomials. The objective today is simple. I can graph polynomials with a graphing calculator. So we are going to center this entire process with our graphing calculator. We're not going to do this by hand like we do with quadratics. We are going to let the graphing calculator do its thing. Now, there's a couple things that we should be able to remember, hopefully, from prior experiences with graphing calculators, but I definitely want to go through those real quick. There's going to be two things that we're really asked to do, and that's to use our graphing calculator to find the zeros or the x-intercepts, and then also using our graphing calculator to calculate the local max or min. So let's start with our graphing x-intercepts here. So what I want to do here is let's just throw in a sample problem into our y equals. So let's say x to the third, variable first, x to the third minus 3 x squared and then plus 4. Let's see how that turns out, see if that'll work for us here. Beautiful. Okay. So what I want to do here is I'm going to use this function to kind of walk us through how to find the x-intercepts and how to find the local maxima or minima. So the first thing I'm going to do is type the equation into y equals, which is what we just did. And then we're going to hit graph. And obviously when we hit graph, we want to make sure that we have a good image here. This is just the standard window. It works fine. All right, now to find the x-intercepts, we're going to click second and then calc. We're going to scroll down to number 2, which is 0, and then press enter. Hopefully this rings a bell for us. We're going to set the left bound and the right bound. So left bound and the right bound. So remember, what that means is we want to go to the left of where it crosses. So there's one spot, and then we want to go to the right of where it crosses. There's another. So notice I'm not trying to knock out both x-intercepts at this time. I'm just doing one at a time. All right, and that's important. And then press enter. And then that x value there is a 0. So negative 1 would be a 0 of the polynomial. See where it says 0 and then negative 1. And that's how we calculate x-intercepts. Now, to find the local maxima or minima, aka the highest or lowest point, so this one has a maxima, it looks like right on the y axis, a minima, it looks like right on the x-axis. We can do that with our graphing calculator as well. So we still type our equation into y equal and click graph. Obviously, we want to make sure we have a good window. And then we can click second calc again. And then we get a pick. Are we trying to find the maximum or the minimum? If we are trying to find the minimum, we scroll down to 3, minimum. Or if we're trying to find the maximum, we scroll down to 4, maximum. So for this case, let's do a minimum. So that means we want to find the lower values. Now obviously we press enter once we've picked that. And then, again, they ask us to set the left bound and right bound. So set the left bound, then the right bound. So let's do that here. So I selected minimum, so I want to get to the left of what I think is the lowest local minimum. So there's the left bound and then the right bound. And basically what the graphing calculator is going to do is it's going to calculate the lowest point. So that lowest point would be at 2, 0. All right, I pressed enter once I have those set. And then the x value and the y value are the coordinates of the point that we're looking for. All right, so there's our local minimum. It's at 2, 0. Now let's try to calculate our local maximum. So our maximum be up here. enter, press enter. And then, now we have e to the negative 7th here, so that tells me that this number is really 0. Anytime we see e to the negative something, I just want you to put 0 in for x. And this one would be y equals 4. So 0, 4 would be our maximum here. All right, and that's how we're going to use our calculators. The rest of the stuff we can pretty much do without a calculator. So here is an example problem here. Identify all the desired information, sketch a graph, and plot on the coordinate plane provided. Okay, so looking at what we've done so far, we have, I'm going to clear our y equals here. Let's type in this equation. So we have negative x to the 3rd plus 5x and then minus 2. And I'm going to hit graph. So I get something that looks like that. Okay. So the first thing it asked me for is my in behavior. Remember, this is what we did last objective. I really don't need the graph for this. I have an odd degree with a negative leading coefficient. So that tells me this rises to the left and falls to the right. It's going to be hard for me to fit this all in. The right. There we go. Okay, and then the other thing, our y-intercept, remember, this is a polynomial, so our y-intercepts always are constant, so this would be 0, negative 2. So then I can go ahead and plot that point right here. So let's look at what we have here. We're going to have 3 x-intercepts. We're going to have a minima and a maxima. So let's start with calculating our x-intercepts. So I find my second calc 0, and then I need to set my left bound, set my right bound, and here's the first one, negative 2.41, 0. And we're just going to round all these to the nearest hundredth, so negative 2.41, 0 would be right about there. And then let's calculate our next x-intercept. So I need to go to the left of this one and to the right. There we go. And 0.41, 0. Puts me right about there. Then second, calc the final x-intercept. Go to the left. And then to the right. And 2, 0. So there are my 3 x-intercepts. And then my local maxima, so that'd be this point up here. I need to second calc the maximum. Need to go to the left of it. That looks good. Go to the right of it. There we go. Press enter. What's my highest point there? 1.29, 2.30. 1.29, 2.30, that'd be right about there. And then my minima, so second calc minimum, number 3, get to the left of it, press enter, get to the right of it. Whoa, hello, everything just moved on me. That was weird. I think I started typing too fast. Need to get to the right of it. I'll go a little slower here. There we go. Press enter. Negative 1.29. And then negative 6.30. So negative 1.29, negative 6, 1, 2, 3, 4, 5, 6. Then a bit more. There we go. And then all I need to do to finish this is just play a fun game of connect the dots. So I'm going to go ahead and try my best here. Remember, smooth curves, nothing sharp or anything like that. And there we go. There's the graph of my polynomial function. All right. Let's do some more of these. Let's do some more. Now, if you would like to pause and give it a shot on your own and then go through it together, you're welcome to do that. But If you want to go ahead and pause the video now and try B on your own, you're welcome to. Otherwise, let's go ahead and knock out letter B here. So I'm going to start by typing this in. Negative 2/3. Careful with the parentheses there. X to the 4th plus 3x squared plus x minus 1. Let's hit graph. Nothing too bad. Come on. Oh, man. Look at all that. That's got 1, 2, 3, 4 different x-intercepts, 2 maxima, a minima. This will be fun. All right. So first off, in behavior, I can see clearly this falls to the left and right. Falls to the left and right. My y-intercept is going to be 0, negative 1. All right, let's get started with these x-intercepts. We know 0, negative 1. So second calc, 0. Here we go. Go to the left of this first one. Press enter. Go to the right. Press enter. My first one's at negative 1.79, comma 0. Okay, let's find the next one. Second, 0. Go to the left of it, then to the right of it. Negative 0.86, comma 0. Awesome. Next one, second calc, 0. Go to the left of it, and then the right. Press enter. 0.44, comma 0. And then one more. Second calc, 0. Go to the left of that x-intercept and then to the right. There we go. Press enter. 2.21. Wow. Okay, so a bunch of x-intercepts here. So negative 1.79 is right about there. Negative 0.86 right about there. 0.44 right about there. And 2.21 right about there. Okay. Now the maxima, I have 2 local maxima here. So let's find those. Maximum. The first one, I'm going to work my way back over here. The first one is in the second quadrant here. There we go. So to the left and the right, press enter. Negative 1.41, comma, see, negative 1.41, comma, 0.92. And now the second one, our maximum again. Go to the left and then to the right. Press enter. 1.58, comma 3.91. Okay, so negative 1.41, 0.92, so not even all the way up there. And then 1.58 to 3.91, so almost to 4, but not quite. There we go. Okay, now the last thing we need is our minimum here. So second calc, our local minimum. Go to the left. Go to the right. Negative 0.17. Comma, negative 1.08. So just barely below our y-intercept here. So let's create our graph here. Just playing a fun game of connect the dots. Remember, we want smooth curves. And there we go. There would be a graph of this polynomial. All right, a couple more and then we'll call it a day. Again, if you want to go ahead and pause and try C on your own, you're welcome to. But let's see how it checks out here. Let's see how C checks out here. Gosh, I'm funny. 3x to the third minus 2x squared, and then minus 4x. Let's hit graph. What do we have here? Okay, so 3 x-intercepts, a maxima, a minima. Well, we can see that this one clearly falls to the left, rises to the right, falls to the left, comma, rises to the right. Fantastic. All right, my y-intercept. So notice I don't have a constant here, so that means 0, 0 is going to be a y-intercept, which also means, hey, I don't have to do the math on that one. It's also an x-intercept, right? If I have a point where they intersect, they are both intercepts for both the x and y. Okay, so I only need to calculate 2 of my x-intercepts using my graphing calculator here. So let's go to the left of this one and then the right. And negative 0.89, comma 0. Oh wait, no, 0.87. Sorry, rounding. I rounded. I skipped that 6 when I did it. All right, second calc 0. Now let's get this other one here. Give me a chance to redeem myself on my rounding. Let's see, 1.54. Comma 0. All right, so we have 0, 0, we have negative 0.87, and we have 1.54. Voila. All right, now our maximum, so second calc. Let's see how we do here. And again, when we do this, the calculator is just calculating the highest point. That's all it's doing with maxima. Or minima is calculating the lowest point. So negative 0.48, comma 1.13. That would be right in the middle of there, just slightly above. Very good. And now our minimum, second calc. Minimum, left, right, 0.92, comma, negative 3.04. So just a little less than negative 3. Right there. All right, and then from there, connect our dots. Again, we want smooth curves, remember? And there we go. There's the graph of this polynomial function. All right, last one. Letter D here. 1/2 x to the fourth plus 2x squared minus 5. So let's put that into our graphing calculator. So I always like to put my fractions in parentheses. I encourage you to do the same. So 1/2 x to the fourth plus 2x squared and then minus 5. Graph. Yeah, it looks a lot like a parabola here, doesn't it? And that's okay, right? We have, let's see, this rises to the left and right. We would have a y-intercept of 0, 5. There we go. Now this one doesn't have a local maxima, so we can go ahead and just say none here. There's no spot where it reaches a highest point and then turns back down. That doesn't occur. It does have a local minima. We will calculate that. It looks like it has 2 x-intercepts, so let's do that. Second calc. Our 0, I can't tell if this is exactly symmetric with the y-axis, so negative 1.32, comma 0. Let's see if the other one is positive 1.32. We shall see here. That's my left bound, my right bound. There we go. It is. Okay, so it looks to be symmetric. If it is symmetric, that means it's symmetric to the y-axis, which means our y-intercept will be our local minima. Let's find out if that's true. So minimum, if it is true, it'll say 0, 5. Again, we're looking for the lowest point for our minimum. Yeah, and once again, it has this e to the negative 6 idea. Remember, anytime we see e to the negative, that's 0. What this is saying is we need to move our decimal place over 6 places to the left. So 0.000000145. So we're going to definitely round this to 0. And indeed, our local minima would be 0, negative 5. And we have negative 1.32, positive 1.32. And this is probably our easiest one to graph. Just remember to make it nice and smooth. And there we have it. All right, hopefully we're feeling confident with graphing polynomials. I know that was a lot. We are going to keep practicing this. If you want to get started on those sample problems or practice problems, go ahead and knock those out. This is Mr. Carter signing off. I'll see you next time.